So Ian and I met at a heavy bit conference. They do a lot in the dev tools space. It was actually Jesse Robbins who created chaos engineering who introduced us. So I knew Ian was going to be a great person to chat with. And Ian has had a storied career. So the places that he's worked, you have heard of many of them, everything from Pivotal Labs to Wired to Autodesk to Friendster. And then more recently, he's been the CTO and founder at a number of startups, ranging from companies at the concept stage all the way through to public companies. And he brings a good view of how to translate from the engineering know-how to the things that the business stakeholders are going to want to hear in their conversations too. So I'm excited to have him bring that into this talk. And I'll say the way this talk came about is I actually saw Ian mention that he had one slide in another presentation he gave where he just happened to mention, here's Ian's 7 wastes. And as soon as I saw the slide, I knew that that was worthy of being a whole talk in and of itself. And so thank you so much, Ian, for coming. And the last thing I'll say is what really excites me about this topic is I know that right now in particular, so many of us are under pressure to do more with less. And so this focus on how do we reduce waste, it's a nice way to get the win-wins that are going to be good for our teams, but also good for the outcomes that we have to deliver. So anyway, enough about me. You're here to talk to Ian. I will hand it to you, Ian. And we'll stop
Great.
share.
And I will start sharing. And where's the there? There we go. Sharing. And let's make sure this is all, does that all look good to everyone? Everyone can see the slides? Great. So yeah, the 7 wastes of software development. It's really a talk about how things tend to go wrong and the little things that we can do and how we can look at them and understand them better so that we can make better decisions. Uh, Lauren did a great job introducing me. Just a little quick backgrounder so that you know what my perspective is, because I think perspective is relevant. I did start out at Autodesk back working for this guy, Ted Nelson, who invented the term hypertext in 1965. This was in the 80s, and hypertext turned out to be a bigger thing than anyone other than him thought. So my time at Autodesk was interesting for that. But and then I went to Wired magazine back when it was first getting started. I was there at issue 1.02, and they had this crazy idea to do something on the internet, which is not what Ted was talking about. Tim Berners-Lee had come up with this crazy thing called the World Wide Web, and he didn't know anything about Ted, and Ted is never going to forgive him for that. So we started this thing called Hotwired, which was the first commercial web application there was, and it wasn't even clear that it would be allowed to run commercial stuff on the internet because the internet was completely non-commercial at the time, all funded by taxpayer dollars, and when that also meant that you shouldn't do commercial things. So I've been really early to things a lot. I was also using Java back when that was 1.0 Alpha 2. The social media thing happened. I was the employee number 3 at Friendster. I was chief architect there. If you want to know about how that did and didn't scale, we can talk about that sometime. You mentioned Pivotal Labs. We kind of did this whole agile thing when nobody was talking about it yet. We kind of commercialized that idea and had this radical idea that when you pay for software development, you should get software out the end and it should work. And that's still kind of not reliable out in the software as like development as a service world. I left there when I got frustrated that we weren't doing enough on the product side. Left for a company called Digital Garage, which is Joe Ito's company in Japan. Basically, a kind of a venture, like it's a venture investment company, but they also developed a lot of their own stuff. I started a company there called Neo, which was about taking this guy's ideas, Eric Ries's lean startup stuff, and trying to bring it to large corporates. He was a general partner there, so it was really good to work with him on stuff in that space. Uh, there was this cool black guy I met had this really nice house. Um, uh, I got asked there to help with some what turned into the U.S. Digital Services Playbook, just a few edits. That was a very different era in American White Houses. Um, I got tired of not like I wanted new challenges, so I figured, oh, Agile's pretty easy. Why don't we do regulated Agile? So I went and worked on software as medical device stuff, and went through the FDA process, uh, uh, bringing a de novo and a 510(k) through them with software while we were all figuring that out. I met uh, Lauren, when I was working primarily focused on Epicenter, which is why I was there for the AI conference, building Gen AI dev stuff. We can talk about that if that's interesting. Now I'm really focused on a venture studio at Healthcare Shares, trying to integrate health um, and agile and health and trying to create good outcomes for humans. And it turns out in a lot of that stuff, there's waste. Even in the government, there is waste. So this is my favorite trash can. This is the literal embodiment of the Paperwork Reduction Act, a U.S. Senate recycling bin. And we're going to talk about seven waste, but the seven waste idea is not my idea. It comes from this guy, Ohno Taiichi, who developed the Toyota production system. So when we talk about lean, the ideas of lean really start with lean manufacturing, which was the Toyota production system. Had his seven wastes, which, they're pretty self-explanatory. Excess production, waiting, transportation, overprocessing. We'll go through each of these really briefly, just to sort of ground it in the thinking where these ideas came in. Um, the idea of excess production is producing more than what you need. Uh, there's These all kind of fit together. I think you'll see. I'm not going to go into these in any depth. I left them in the slides, so if you want to go back and read about them, you can. Um, Excess production is a big thing. Waiting is a big thing. Time that you're not actively engaged in the thing that you're really meaning to be doing is a thing. Transportation is another sort of kind of that, right? Like moving things from one place to another so that they can be assembled. That's a big cost. Uh, Overprocessing is really about doing more work than is necessary. Um, Excess inventory. This is kind of a big one. The idea that inventory, like prior to Onataichi, everybody sort of thought, oh, inventory is value. And he really turned that on his head, sort of talking about the idea that inventory actually isn't inherently valuable. In fact, it's a cost center. Things go bad, things become irrelevant. Um, it's really a subtle point, though. It's a change in perspective. And what I hope in all of these ideas in this talk is that I can help sort of change your perspective to think about things a little bit differently and give you a different lens so that you can sort of dig into these ideas. And I'm going to go into this one a little bit more depth than because we'll come back to these ideas. Inventory is waste. This is, again, not the intuitive model. Usually we think of as inventory as value because we can sell it and we have it already. But it is waste because it has a cost, uh, but it hasn't produced any value yet. And I think that's a way to think about things like we're producing things in order to produce use value. That's a theme that we'll come back to a lot in the course of the talk. Um, Sorry. Bills are a little bit tough when you accidentally hit the wrong button. Sorry. Um, Come on, go to the next slide. There we go. Unnecessary. This is a great example of unnecessary motion. That was unintentional to provide you that example. Extra movement by workers, like little things like how is the shop floor set up? How do we create inefficiencies from these sorts of things? Um, these are all very manufacturing centric, obviously. Defects, a really obvious thing. We know that defects are a problem. Everybody knows that. That's pretty obvious. Um, there may be one of the most visible forms of waste. And all these ideas really resonated within the lean startup community, within the agile community before the lean startup community. And I sort of took that and found that there were a lot of resonances for me personally with how things did and didn't work in software. And I really developed these seven wastes: unvalidated design, unpaid code debt, pre-optimization, time you spend stuck or unfocused, duplication, over design and over architecture, and the classic done not equaling done. So let's go through each of these in turn. And I'll explain what I mean by them all, and I'll give you some examples. So here's a classic example of unvalidated design from the physical world. This is the Tacoma Narrows Bridge, which looked great on paper. They built it, and it turns out it had this awkward tendency to resonate when wind blew by, which happened quite a lot. And people don't realize that the bridge is called Galloping Gertie. It's the bridge that failed in Tacoma Narrows. It actually was up for months and people would drive over it and sort of do this waving thing as you drove across it. But one day the wind conditions were just right and it resonated itself into destruction. Nothing bad happened to it other than the wind blowing. And this is a sort of a classic example of where they thought the design was good. they built it, they deployed it, the design wasn't good for a subtle reason, and it failed. So, but the idea of not being sure of things, that's kind of endemic. It's not inherently the it's an inherent problem that we can't really work around. The problem is that from the time you make a bad design decision till the time you discover a bad design decision was bad, everything in the meantime is really wasted effort because you're predicating your next decision on things that it turns out were not valid. And so, as I said, that's actually, you can't really get around that. The problem, though, is when you sort of do a waterfall approach, the time between when you make the bad design decision and the time you discover the bad design decision is really, really long. A month, a year, sometimes longer. Even more perniciously, usually it's not until after you launch the product that you find out that your design decision is wrong. That's true in that bridge example, but that's true in many, many software examples. But as I just said, you can't really avoid this. You are going to make bad design decisions. So how do we fix it? Well, an iterative approach fixes this by finding out sooner. It's not that you're not going to make bad design decisions, it's that you're going to discover sooner because you're going to test it. You're going to user test it, you're going to actually use it yourself, and you're going to then focus on getting that information earlier. So the solution for this is to really to optimize for the speed of learning. Think about how can I find out sooner if my decision is wrong, rather than waiting until you've launched or until it's really hard to fix. If you change the time scale by shipping fast and shipping often and learning quickly, that problem, which you aren't going to avoid, becomes a much more manageable thing. So that's one waste. The next waste we're going to talk about is code debt, and this is a fun one. This is one of my this one I also would love to make into a full talk because it's actually quite subtle. Um, there are really two schools of thought on code debt, and the first school of thought is code debt is bad. It is really, really, really bad. It must never be allowed to creep in. Every effort must be made to eliminate it. No cost must ever be spared. The totally other school of thought that's actually more popular, and that school of thought is, what is code debt? So probably if we're on this call, you probably are more in the first school, but let's unpack this a little bit. What does code debt really look like? Uh, Code debt can look like buggy code. It can look like copy pasted code. It can look like hard to work with interfaces. It can look hard to instantiate objects. Uh, Anything that creates extra cognitive load when you're developing is a symptom of code debt. You have it when things that should be easy aren't. Uh, but you also may not know you have it, even though you have a lot of it. And I think I see this more often than I see people who are really aware of it and managing it. Often you're so used to a polluted environment and your expectations of what developer performance and throughput are so poor because of bad practices that have been allowed to continue for so long. Often the frog doesn't know that the water is getting really hot, right? It's a question of, can you even detect it? Um, why is code debt bad? Well, code debt is bad because it makes software development slower. And it really works like credit card debt. For every unit of time, the more code debt you accumulate, you have an interest payment that you have to make because you're going slower and slower. We've all been involved in software projects that were really fast at the beginning, but by the end, it took forever to do anything. Uh, every time you don't, so every time you don't pay down the code debt, the code is going to go slower. Your process is going to go slower. Um, but it's still cheaper to not pay it down at the time for the moment, for the small thing that you're doing. And I think this is the tension in it. And I think this is also, if it's so bad, why does it exist like this? Um, Paying off code debt is expensive too, but it's less expensive than making interest payments over and over again. Um, it, that said, though, it really does work like other kinds of debt. There are times when you actually want to take it on. There are times when it may make your project more expensive overall, but you do get a result more quickly. And this is the human side of it that makes people incur code debt at an alarming rate because I just want to do this little thing. I don't want to fix this other thing that's been getting worse and worse. I'm afraid to look at this thing that's been getting worse and worse. And if I just do this one thing and then stop, then I have this extra little bit of value. But the problem is that I've now made the cost of paying down the code debt higher. Um, it's not bad or good, but if you ignore it, it will eventually kill your project. And actually, when you take it on for the right reasons, it can be really good. And we're going to talk about that a little bit too. But it's mostly either bad or really, really bad. Um, so cool. Taking on code debt is about cutting corners. It's great to cut corners, but you have to then know when you need to glue the corners back on. Um, if you're cutting corners to get something out the door quickly, that can be really useful, even if it costs more overall. If you need something valuable this week, sometimes you can't. Sometimes it's still the right decision to take on the code debt. If it's like, I have a demo on Thursday, I could refactor the entire world on Wednesday and not have anything for my demo. Sometimes you need to make the choice that I actually am going to incur the higher cost. Uh, but I also know that if I do that forever, I'm going to get so slow that I'm not going to be able to produce anything. So taking the time to invest and put money back in, putting the corners back on that you cut off after the demo is really, really important. Um, the other special case is code debt bankruptcy. If you're doing something and you learn that you're not going to continue it and you throw it away, that's actually an incredibly powerful thing to do. There are a bunch of different cases of this, but like this is part of the reason why people put prototypes together is because you want to do something cheaper to learn from and get something out the door and see and validate that your thesis, your hypothesis is correct. So if I write a piece of software, a really poorly written piece of software, and I can do it in a day and get user input on, then I've learned something really valuable, and that day is throwaway. But I know that I'm on the right path, and I've saved time in the future by not wasting time on something. Even better, if I find out my idea was terrible, I only spent a day on it, and I don't spend the next 6 months building the thing that wasn't going to work. Um, there are there is then, and even in the hardcore agile code debt is bad and should never be incurred space. People do think about doing things called spikes, right? They will do, I'm going to try this out and see if it's any good and not really worry about it. But then they don't keep that code, right? Like they declared bankruptcy on that little piece of code that they got the learning from. They still got the learning, but then they write it properly afterwards. The most dangerous place, though, is where you take that prototype code and then you just keep adding features to it and you never clean it up and it never becomes maintainable and the cost curve goes asymptotically worse. Um, you can fix that by paying down code debt on it. If it's in good enough shape that you can refactor it into something maintainable, that's fine. But the right answer, there's always a tension, right? And I think there isn't just a simple answer that you should always do this and you should always not do this. And I think throughout the talk, one of the things that I want to sort of try to emphasize is that there is art in deciding how to approach these things, but being intentional and being aware of the trade-off that you're making is really the most important thing that you can, I think, take away from this talk. Um, it's important to make time to manage your code debt. You are going to incur it, and when you need to incur it, you need to also pay it down. Uh, every every code base in existence, even by the most diligent developer, has code debt in it. And some of that code debt's worth paying down, and some of it's not. If it's hurting you, fix it. If it's not hurting you, that's fine. I think trying to do like a cleanup week is a great thing. Really, you should be doing it all the time. Every time you touch something, refactor it for cleanliness. Like the red green refactor cycle is that for a reason. You write the code with the red tests, you get the tests passing, and then you refactor it. Then you get it nice and maintainable and get it ready for the next developer to work on. Um, the important thing is understanding the impact. Uh, and if you have a management team who doesn't understand why you would want to do a code cleanup week, as a developer, it's your job to help make visible the consequences of that choice so that they understand that what you're proposing is not in opposition to their needs. One of the questions we had ahead was like, is efficiency the most important thing here? And it's not the most important thing here, but it is a thing that helps those people who are arguing against better practices because they are unaware of the impact of those practices. it's a way that you can help to sell the need to do some of these things. Uh, so, again, knowing when to declare code bankruptcy is really important. You can either pay down your debt or you can write it off, and it's really liberating to write it off. This is why we do rewrites sometimes. Sometimes the code base is so bad that the right thing to do is start fresh, and that's never the right decision, except for in the context of many other poor choices, right? So people shouldn't choose to do a fresh rewrite unless that is genuinely the best way to get further faster. And I hate doing it, but I've had to do it several times. And when I've had to do it, it's usually been the right choice. Um, you can't usually stop the world to fix it, but if your course of development is too slow to get to your end date, looking at radical steps like a rewrite is often necessary. Um, the big takeaway on code debt for me really is don't incur it blindly, right? Like, be intentional. Uh, if you're copy and pasting things to go faster and don't clean it up, then you're creating a giant mess, right? Like, it's not going to save you effort. It's going to save you effort today, but it's going to cost you more effort next week and every week until you fix it. It's cheapest to prevent code debt by doing a good job the first time, and then the next cheapest is to repair it right after. Uh, you should only knowingly incur it when there's a really good reason. But again, there are many very good reasons to do so, and if you do it intelligently and judiciously, the same example again of doing a prototype, it can be very useful. Um, the time to take on code debt is when the rewards outweigh the costs. The costs are substantial. It's the same as regular credit. There's times like when you just should use credit because it's going to get you an outcome that you wouldn't have available to you otherwise. Um, Sometimes you need to test an idea to see if it's worth investing in. Sometimes uh, that learning is the thing that you're going to take away from it. Sometimes you need it for an investor meeting. Sometimes you get it to prove that your idea is right. Um, But if you think about the long-term cost and where you're trying to get to, that's a good lens to look at it to see, like, are we keeping the code in a state that's uh, good for long-term maintenance? Um, One special case where you're really going all code debt is I love to do a bake-off. If I'm trying to choose a tech stack on a team, having the team actually spend even a whole week developing if you do a little bit of sensible selection and pick out uh, the couple of leading candidates, and then you actually build the thing you're trying to build, a little bit of it in two or more tech stacks. Nothing is going to tell you how much you're going to love or hate a framework or a tech stack as actually trying to build in it for a week. At the end of it, you're definitely going to throw away one of them. And so that's a special case of debt where you're taking on that debt, but the debt then rewards you with a much cleaner, much more efficient future development path, and one that everybody's signed up to. And there's a lot of things that come out of this that are not in the talk, but like getting the team on board with the tech stack choice is one of the most important things that you can do as a team leader. But that again, like that's really a whole separate talk. Pre-optimization. Uh, Solving for future problems we may not ever have. We must plan for scale. We must think of every future edge case and ensure that none of them are that nothing we ever do will ever degrade performance. We will go faster if we design it all up front. If we don't plan for it now, it won't happen. Problem with all these things is they are wrong. Um, the reality is future scale isn't going to arrive if you can't get the product out the door. The biggest scaling problem any startup ever has is nobody cares. There's no scale because nobody uses it. And, you just spend a bunch of money on something that nobody cares about at all. The fact is, at the beginning of the process, you don't know enough to actually know where your performance bottlenecks are going to be. Optimization is inherently a problem of solving for shifting constraints, for real constraints that exist at a certain order of scale, and trying to pre-optimize for it is is a fool's errand. It's not something that rewards you. Uh, Now, when you have real scale issues and you have real data, and then if you have well factored and well tested code, it's much easier for you to do optimization of performance. It's easier to, and it's less work. It's better suited to the actual demands, and it doesn't create damage. The process of optimization doesn't damage your product because you have well factored, well tested code and that's resilient to change. Um, but just because we're not pre-optimizing it doesn't mean you can't follow good patterns. We already do all know a lot about what makes a good scalable architecture. Uh, Using established patterns uh, is good. Uh, okay, we know we're going to factor things into horizontally scalable controllers, and that they're going to have we're going to use REST, and we're going to use all these like fairly standard things. Uh, you don't have to be dumb because you're not pre-optimizing, but you don't. But what you shouldn't do is actually optimize. Take good patterns, apply them to your thing. Keep everything well tested so that when you do have a performance issue, you have the data to show it, and you can test that you're actually improving that you're moving the needle that you need to move. Um, but what makes it pre-optimization? It's not pre-optimization if you already know what your performance needs are. If you know that you're launching in 4 weeks and you're expecting to have everybody who is an existing customer for some other thing on your system the first day, you better make sure that when you launch it, that it can handle, 400,000 users and 25 transactions per second or 300 transactions per second. Um, it's not pre-optimization again if you're following good patterns. It's not pre-optimization if you're solving performance needs that you know that you will have right away. It's easy to delude yourself that you're going to have them, but if you know, that's not pre-optimization. One of the classic agile phrases is "you ain't gonna need it." Even if you're pretty sure that you about the optimization you need up front, you'll probably be wrong. You might be close, and you might be way off. And if you spend a bunch of time optimizing, you wasted development time. You compromised your architecture for needs that you don't have. Uh, if you haven't shipped something because you spent a bunch of time optimizing it, you've really done a bad job. And if you've delayed getting the information you need to optimize properly, again, you're hurting yourself. Um, and so that's pre-optimization. There's a whole other waste that's a little more subtle, which is the time you spend stuck or unfocused. It turns out as developers that when you're in the zone, you go really fast. You could be doing same developers working on the same thing, and you're in the right headspace, you go super fast. At other times, maybe you go a little slower. Um, and what's different is often not even the problem that you're trying to solve. It's just where your headspace is at, and subtle differences. We spend a lot of time as developers stuck or unfocused. The time in development really kind of goes to, I'm not quite sure this API. I'm not quite sure the stack. I'm not really sure this best solution here. Oh, here's a really hard problem. That's kind of a legitimate one that you expect to spend time on. But it's surprising how often you get stuck on a really easy problem that on any other day that you would take you 2 seconds, and it's quite surprising sometimes how much time goes into things like that. Um, if you are uh, Sometimes you're just stuck on something you've already solved once before, but like, what was the solution there exactly? And then the other thing is, as I can say this as a developer, a lot of us have attention deficit disorder and are easily distracted. And I think that's something that we don't also really, we pretend doesn't exist. But that's actually a thing that a lot of time goes into. I'm going to give you a classic Agile answer for what I think the best thing to do here is, and that's pair programming. Um, Pair programming is really natural to us when we're stuck on a hard problem, but it turns out describing what you're doing and working with somebody through it changes your engagement. It changes your ability to solve problems. You don't get stuck as easily because the other person will not get stuck at the same place that you'll get stuck. That other person could be identical to you with exactly the same information, and on a different day you do get stuck or don't get stuck. And that interference pattern of having two people working on it really changes the engagement. you're not going to get distracted if you're engaged with a partner working on something. Uh, and you're not stuck on your own trying to figure something out if you run into a problem. Uh, Also, if you're new to Agile or things like it, then you can learn things like TDD and various other things and don't get stuck on these sort of core ideas. Um, Rotating pairs also shares knowledge to the team. Everyone touches all the code. Everyone learns how everything works. Anyone can code in confidence when they have the right exposure. And if you don't know what's going on with something, you can go pair with somebody who does, and the knowledge will magically go into your brain in a way that is the rate of knowledge transfer with pair programming is unlike anything that I've ever seen in software development. Yeah, some AI stuff's getting close, but the concrete life story is my first day working at Pivotal Labs. I was working on a code base for eBay, a very complex code base with layers and layers of data transfer objects and various other things. I sat down with Elizabeth Hendrickson, my pair for the day, never saw the code base. Within 30 minutes of sitting down, I had my first commit, and that was because she knew how the code worked. And so we were like, what are we trying to do? Oh, we need to do this. Like we had the user story. I need to update this user with this piece of information. Okay. As a newbie, you'd come in and like the first 2 weeks be trying to figure out how the code base works. But I could say, oh, we need to get the user. Oh, okay, go get the user data. We load it up and use the grab the user out of it. Okay, now we need to, well, what do we have on the user? We need to know what their transaction history is. Okay, well, you use this object. And we built something and committed it within 30 minutes of me sitting down for the first day at my new job on this new code base. That's a remarkable rate of knowledge transfer. And I was able to apply what I knew. Like I added value because I had all my engineering experience and I had somebody with me who could show me where the things were so that I could be effective right away. Um, it also makes the day go fast and is really quite enjoyable. And there's a whole other thing about somebody also asked, is efficiency the most important thing to measure? I think we already touched on that. Um, it turns out developer happiness is very strongly negatively correlated to waste. Um, so it turns out if you do these things to make your work process healthy and good, then everyone feels better and is more productive, and people actually want to be productive, it turns out. Duplication. Duplication is one of the most common forms of code debt generation, and that's taking the same thing and putting in multiple places with subtle differences. It makes it really impossible to keep track of what's going on. If you once you find when there's a bug, and there will be, because we saw that in the very first couple of slides, um, it turns out if you then duplicated it, you then have to fix it every place, and you have to find it every place in order to fix it every place. It turns out that really being rigorous about factoring things into reusable components goes an incredibly long way to making you more productive today, but incredibly more productive over time. Um, that was a picture of pasta. Do not copy pasta. Um, uh, if you have something in your code, do it one place. Composition is a very powerful abstraction. Uh, do that. Don't copy paste. Uh, it's fast in the short term. I have this thing that does almost what I want. But if you and it's fine to do that first, but then refactor it into like, what are the commonalities? How do I reduce my duplication in my code? If you do that all the time, you're going to have so much aggregated productivity that you can do all sorts of things that you would never be able to fit in otherwise. Um, and there's a lot of words in there that you can, if you want more examples, they're in there. But again, the slides are there also as a leave behind so that you can read stuff later. Uh, One of our last couple is over design and over architecture. Uh, this is the other evil twin of pre-optimization. It's this pre-optimization on the strategic level. We often build architectures that are way too elaborate for the job they are trying to do. We like to be clever. We are engineers and we like to solve complex problems, even ones that don't exist. And we tend to over-apply patterns that work, and that's problematic. Um, you know you have it if like a good design will reduce friction and over design increases it. Good design reduces complexity, over design increases it. Good design improves performance, over design reduces it. Good design improves team performance, over design radically reduces it. That said, sometimes it's really subtle, and sometimes the right design is complex for a certain complex problem, uh, but would be total over design for another problem. So it does take art and insight to be able to answer these questions. Um, One thing you can do is sort of a Marie Kondo approach. Does this design spark joy? And when I'm not talking about for the end user necessarily, but for the developer and the person applying the design, is this design making my job easier or harder? Is it making my deployments simpler or harder? Is it increasing my throughput or my latency? Um, get developing a nose for over design again, like I'm guilty of it. It's so much more fun to come up with a clever solution than a dumb one, but usually the dumb solution is the right one. Um, is there things that you can do to fix it, or ask yourself, is there a simpler way to do this? This is also, by the way, if you pair with a junior and the junior gives you the really dumb answer, and you go, wait, that would work. That is a sure sign that you've over-designed something. Um, don't let you think the dumb way is too dumb unless you have evidence that it won't work. Sometimes the answers don't line up across contexts again. Like sometimes you need something complex in one place, but a simpler approach is fine in another place. Uh, but if it's something you need, it's not over architecture. The over part comes when you're trying to solve a problem that you don't actually have. And if you find yourself in that spot, it's worth re-examining if there's a simpler way to solve what you're trying to do. And that brings us to the very last of the seven ways, which is done not equals done. This is my favorite in that it's my least favorite. It happens in every project that I've ever seen. Uh, what does that mean? Done not equals done is the idea of thinking you're done when you're not and getting part of the way there. Done equals not equals done is about I did all the work but got none of the rewards. If I did 90% of something, uh, what value did I get out of it? None. If I did 99% of it, what value did I get out? None. The only thing that you're getting is that you're closer to done. And so I've seen this problem on teams all the time where everyone's working on 20 different things, but nobody's finishing anything. If you do one thing, if one thing comes out of this talk that you can help on your projects, and it's to actually get things all the way finished instead of most of the way finished, you will see a huge increase in productivity. I guarantee. Um, the my first day at one of the companies that I have a whole other talk on, uh, they asked me to evaluate where things were, and I noticed that they were 6 months into a 2 month project, and that they were 2 months from completion. And uh, I looked at their backlog. They were using Pivotal Tracker, which I was very pleased with, but nobody was starting things in the right order, and there were it was a 6-person team with 30 open tasks. There should never be more open tasks than team members. That is kind of one of your smells to look for. Uh, you can end up with an awful lot of stuff done, like started but not finished. They all add cost. They don't add value. Uh, Another special case of this is when we think we've gotten done with something, but it turns out we haven't really. We feel finished when we've gotten to the point where we've solved the hard problem, but it's actually then taking that and putting it, committing it, getting it merged into master. That's where you actually where anybody else gets benefit from it. Um, we feel like we did a lot because we did the hard part. It's often the easy parts that get left out, not the hard parts, and that's kind of counterintuitive too. Uh, and of course, the longer you're not on main, the more likely something else is going to conflict with it. So if you can get, I mean, this is also where you want to try to drive to really short commit cycles, really practically. If you're not committing multiple times a day, you're kind of doing it wrong. There are places for long-lived branches, but they're rare. Uh, the, and if you're doing that all the time, the small increments of work are really easy to fix when something comes apart. Um, Closing that feedback loop is really critical. If you're not running a regression test, if you're not committing to version control, you're not getting your PR feedback and not getting merged, and then not validating that what you built is what the product manager actually intended you to build, then you're not done. Like having done work is not the point. Having completed work that is what is desirable for the product, that is the point. Um, and it's really even that's only the beginning. Until we ship, there's no real user value. We don't know what we built is fit for purpose. We don't know the customer is going to care. Uh, we don't really know what else we have to do to get to product market fit unless we're getting it out to customers all the time. And I mentioned how sometimes it's the harder part that feels easier to do. Unfortunately, especially in the United States, we have the Protestant work ethic, which has told us that the thing that's valued is hard work, not results. We've been taught to work harder instead of smarter, and that's not great. This is the same thing with the clever solution. This is where over-architecture also comes from, is trying to be too good at something and trying to do things that are hard for you. You should do stuff that's easy for you because it's easy for you because you know what you're doing. Um, One of the big things here is that just remember that we are accruing cost the entire time we're developing, but we're only accruing value when we ship something. So if we can get that unit cycle down to a small cycle, we get a very different outcome. The work we did isn't valuable until it produces a user visible result. Uh, it's great to appreciate the effort somebody puts in, but the value isn't in the effort, it's in the output. If you can do it really dumbly, and like if you can do a 4-hour work week and produce as much as everybody else, awesome, do that and then spend more time on the beach. Um, Doing more with less work is good for everybody. That's good for the company, it's good for the individual, it's good for people feeling good about what they're producing. It turns out heroics are expensive and don't do them. When you take this approach, when done actually equals done, things start to flow really smoothly. Turns out if you're doing things in small increments, the work gets really predictable. The throughput gets really obvious. Everyone's understanding what's going on, and then you actually start to get user feedback faster. And those small merges, again, are just not nearly as painful. We get value when we ship. Um,
That's great. I might,
yes?
and I'll just do a quick time check just because I know we have 10 minutes and some questions. So,
Yeah, we're almost at the end.
great.
Okay, so software isn't an asset, it's a liability. This is a big mind shift. I mean, I sort of alluded to this at the beginning when we were talking about inventory. Uh, that's really weird, right? If your job is to create this thing, to think of it as a liability. So what do I mean by that? It's really that excess software is a liability. We do need software in order to produce use value. We need software the other place that we use software is to reduce other costs. If we're simplifying a process or making it automated, that produces value, but there is a cost to managing the software. Software is the necessary infrastructure to produce that use value. But we should be producing as little of it as possible to produce that functionality. Um, it's a liability because if you have too much of it too early, it means that you've incurred expense without receiving reward. If you make it ahead, it's probably not fit for purpose. It's likely not to get used. The more software where you produce, the more you have to maintain. This people do not think about the maintenance cost nearly enough. And all of these little factors that make your software hard to maintain are multiplicative. If you have bad code quality, that's a multiplier. If you have a lot of code duplication, that's a multiplier. If you have a lot of code debt, that's a multiplier. And each of those multipliers then increases their cost of development, but then even more so increases your cost of maintenance. It's a liability, and we used to think of it as an asset. It takes time and effort to maintain and operate. And that cost is a logarithmic function of the amount of code and the quality of the code. So we do need it to produce use value. It's necessary infrastructure to produce that value, but we should produce as little as we can to get what we need. So that's really the 7 wastes. Uh, you may have questions. I know you have some questions. Thank you for listening. This is my town, San Francisco. Um, Thanks for tuning in. And with that, I'll leave the slides up, but we can turn it over to the questions.
Yay. Thank you so much, Ian. I saw Lots of nods. Lots of this resonated for me personally too, I can share.
Awesome.
So yeah, Jen, you did a call. Start putting questions in the chat if you would like to. I want to kick us off with one of the questions that was sent in advance as well, um, that I think probably resonates with a lot of people. So curious to hear from you, Ian. How do tech leaders create environments that
Yeah.
can enable a focus on identifying and removing these wastes? And because I think it's, I'm just going to add to that question because I think there's an underlying insight here, which is we all look at this and we say, yes, this is great, of course, right?
Right.
And then in practice, we get busy and it's hard to do these things that are good things to do. So, yeah, what have you seen works for
Yes.
actually staying on top of these?
Well, and I want to unpack what you just said. We get busy and it's hard to do these things. And it turns out when we get busy is when we need to do the most. Um, the one word answer to the question is retrospectives. I think that building a learning organization is about listening as managers, but as team participants, and not sort of treating it as this, like, our job as leaders, in my opinion, is to support our teams and make sure that they can be productive and that they have what they need. I want to be a facilitator and a collaborator with people. There are definitely places where my experience will expose things that others with less experience are not going to see. But that said, usually everybody can feel it, what's going wrong with the team. To do that, you need to have a really clear trust environment. You can't do that if people who speak up are harmed for their statements. You have to have a thick enough skin to accept that the things that you're doing aren't perfect yet, and that people's criticism is worthy, even if their criticism is misaligned with, even if their diagnosis is wrong, the symptoms that drove them to that criticism are always real. And so I think if you want to adopt one thing that you can do to help apply these things, it would be to have those retrospectives. I like to do them at least every 2 weeks and have a good like couple hour discussion. Um, put up your topics, classic agile retrospective, put up your topics, dot vote on them, and get everybody talking about them. Do it over beers or whatever. So make it a social thing that's non-threatening. But the hardest job there is as a leader is to make it really clear that you're listening and that you're not judging, other than you're judging the issues but not the people, and you're trying to help everybody to be productive, um, and that no topic is out of bounds.
Great. Yeah, great one word answer. With the exposition after.
Yeah.
We've got some great questions coming through in the chat, so I'll jump to those.
Mhm.
So one from Kevin, which plus one to that because I had some more questions around this one too. So code debt, big topic. You gave us some great insights on that. Curious, the question here is how do you get buy-in from leadership to work on code debt? Or as an engineer, part of that is how do you make that code debt more visible to the wider team?
Yeah, that's hard, and it's storytelling. The real answer is to uh, I think it's a multi-step process. One is to learn in yourself why it's so bad, right? If you feel what this is costing the team and you can express what this is costing the team and why it's so damaging, you have a much better chance of winning hearts and minds. Um, I think some things that I've found are useful are to talk about how things used to be better when the code debt was less bad, and showing how this increase in productivity, without with very few variations, the code productivity goes down over time because code complexity goes up, right? And so if you can talk about, remember when it was we could just do features really quickly, and then you can explain that what's different now is that there's so much complexity that hasn't been managed, and that the process of managing it is how you get greater future productivity. I mean, that said, there is definitely art to that conversation, and I've left companies. Ultimately, I left one health company when I realized that the people at the FDA understood what I was doing in terms of productivity better than like pharma co-founders. Um, you may not win the argument, but I think the best you can do is to sort of show why that is so important. You then have to also be able to demonstrate it. And if you show and sort of talking about productivity before and productivity after, if you can collect data and use that data to support what you're saying, I think that's really useful. Um, but you have to win trust and you have to get other leadership to understand that deferring, it's a two marshmallow question, right? Like if you let me spend next week trying to get things in better shape, all future weeks will be cheaper. The economic argument is very compelling if it can be brought across. And if we know in our hearts that this is going to be the thing that fixes this problem, that's going to help us sell that idea. And then you can demonstrate it after and say, see, when we made this change, this is how this went. Also, if you have multiple teams, having one team do it, like say, look, we're just going to do it in this one team just as an experiment. You can see. Uh, like, and God we trust, all others bring data. I think it turns out that you can convince a lot of people by showing the difference, and some of it is visceral. It's really a storytelling question in the end.
That's great. And I love that framing of just start small, little experiment, and then, go from there. I want to squeeze in one more question before we run out of time. So from Kashif, how do you get buy-in for this? And feel free to jump in, but I'm assuming this means this approach to managing wastes. Um, so let me know if not. But yeah, how do you get buy-in to this approach to managing wastes from sponsors who are often non-technical? And things like the benefits can often be non-tangible at the start. So Kashif, feel free to jump in if you have anything to add to that. But I
Yeah.
would,
I think, yeah, thank you so much. I think it was just answered by Ian. So it's a matter of showing tangible benefits and
Yes.
trying to show them upfront a little bit early
Yeah.
and in the form of an experiment with the hypothesis. That sounds good. Thank you so
Well, and I
much.
think being real about that it is a cost, right? Like I think having empathy with the stakeholder to say, look, that does mean we're not going to get this feature and this feature done this week, but we are going to get them done next week. We're going to over the next month, we're going to get 10 features done instead of two. That's a compelling argument.
yeah, that's
Um,
great.
yes, but it's just that this is a matter of persuasion as well because
Absolutely.
yeah, a lot of people would be skeptic if you promise that I'll get double the features developed next week, you know.
Yeah.
But
And
on the
sometimes
other
it doesn't
hand,
work out that way.
yeah, yeah, because yeah,
Yeah.
you do find unearthed stuff. But yeah,
Yeah.
That's great.
there needs to be a little bit of a hypothesis creation and you know seeing how we do this experimentation rather than actually committing and saying that this shall be done, this will be done.
Yeah, I agree.
Yeah, that's good.
Falsifiable hypotheses are really good, and then you show data, and then it tends to be more compelling.
That's great. I
Indeed.
see
Yeah.
Tobias.
Thanks.
Oh,
Mhm.
sorry. Yeah, thank you. I see Tobias has his hand raised. So what I'm going to do for those who need to jump off, we have a survey. We love to hear feedback. So Ginny's going to put that in the chat. We also have a Slack community where you can jump in and continue the discussion. So just for those who I know might have to jump off in a minute, feel free, go ahead. You'll see that in the chat in a second, and then you can follow up there. And then Tobias will hand it over to you. So for those who can stay for a few more minutes, we'll make this the last question. And thank you everybody for coming. We appreciate it.
Yeah, thanks so much. Thank you for your time. And Jared's here to answer questions too.
I actually wanted
Awesome.
to help, answer or provide perspective. So I work with engineers quite often who say we need to rebuild, and one common theme is they ask to stop shipping features in order to do this big rewrite, and
That's not
that's the
going
one thing that
to
will
happen.
never happen.
The world doesn't
So
stop, it turns out.
exactly.
Yeah.
So figuring out how you can show an approach, how you can do this in manageable chunks of work, I think is really important. You need to make this a low risk proposition.
Yeah, do it incrementally. I mean, the approach is about incrementalism, but you have to approach the fix incrementally as well. And again, with evidence and show a lot of it. This is also where having regular retrospectives helps too, because you talk about what's happening and then you see the results, and then you can get the awareness of how this change impacted what's going on more broadly spread. And then that tends to resonate too within teams. But yeah, the world doesn't stop because you want to do a big rewrite. A rewrite is always the last resort for that reason.
That's great. There's one more question just while we're here, and like I keep saying, this is the last one, so we'll make this the last one. But I know, Ian, how great you are with provocative questions. So Noah, do you want to ask it, or do you want me to read from? I can read from the what you've posted in the comment if you like.
Well, I was responding to someone else's comment about getting buy-in for solving code debt. And the argument that I usually use is that it's the wrong perspective to take. The only person that knows whether or not code is finished is the developer, which means when a developer then gives someone else who doesn't understand what they're doing the power to say, yes, this is done, or no, this isn't, or no, you're not allowed to do this, they're essentially advocating professional responsibility for looking after the things that they're responsible for. And that's a really difficult position for a lot of developers to accept that they're in.
Yeah.
But it's actually really important for them to accept it if they want to be able to fix debt when it needs to be fixed.
I think that's true. And I think every shape of organization is subtly different around that too. Sometimes you can get buy-in from product management and that helps. And because ultimately what we're trying to do is produce use value. And so if you say, look, let's not talk about what's happening this week. Let's talk about what's happening this month or this release cycle. And let me do my job, to your point, to get more stuff done by the time it matters. And let me do my job. Like, it's subtle, but it's important.
Great. All right. Well, big discussion. I know we're getting into the rich stuff right at the end. I also know we're over time. So just a big round of applause again. Thank you so much, Ian, for taking the time to share your insights and your experience with us. Thank you to all of you for joining. As I mentioned, the survey's in the chat. You can jump in the Slack community. We love feedback, so any and all feedback is welcome. And otherwise, watch this space. We've got our next speaker getting planned in the background, so updates on that to come. But yeah,
and if
thank
you
you all
have
so
stories
much.
about how you've seen these things happen or not happen, or criticisms, or any of it, I would love to know that as well. Reach out. Lauren and Co can share my LinkedIn and stuff, and reach out.
Great. Thanks, everyone. Have a great
Thank you.
day.